Hi, welcome to Data Science Byte-Sized Learning. In this video, I will discuss support vector machine algorithm. In my previous videos, I explained different types of classification machine learning techniques. In this video, I will discuss support vector machine, which is the last one in the classification algorithms I have picked up for this learning series. Support vector machine is responsible for finding the decision boundary to separate different classes and maximize the margin. It is based on the idea of finding a hyperplane that best classifies a target into two classes. Hyperplane is an n-1 dimension subspace for an n-dimension space. In two-dimensional space, this hyperplane is a line dividing target variable into two parts, where each target class lies on either side. For a three-dimension space, its hyperplane will be a two-dimension, which is a plane that slices the cube. SVM is used for both classification and regression purposes. Mostly it is used to solve classification problems. How do we best classify the two classes within the data? The answer is to choose a hyperplane with the greatest possible margin between the target classes. The distance between the hyperplane and the nearest data point from either set is known as margin. Intuitively, the farther our data points lie from the hyperplane, the more confident we are that they have been correctly classified. We therefore want our data points to be as far away from the hyperplane as possible while still being on the correct side of it. So when a new data set is added, whatever the side of hyperplane it lands on will decide the class that we assign to it. In reality, most of the times data is not linearly separable. When the data is not linearly separable, then additional parameter is added to separate the classes. This is called kernel trick. These are functions that take lower dimensional input space and transform it into a higher dimensional space. That is, it converts non-linearly separable problem into a linearly separable problem. Then, in this new higher dimensional space, data is made linearly separable and target is classified into separate classes. Now that you have understood how SVM works, you have to tabulate confusion metrics to calculate accuracy and other metrics. Refer to my previous classification technique videos on how to tabulate confusion metrics and calculate accuracy and other metrics. Hope you enjoyed this video. Thank you, and we'll see you in another bite-sized learning video on data science.